It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date. With the best of the questions by best educators till date. With the best of the questions by best educators.
with detailed solutions from top educators right after each contest.
combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Combat. Register now. Combat. Register now.
Welcome to Unacademy SN YouTube channel. This is K Umamaheswara Rao. Today we will be discussing properties of determinants. Determinant and properties of determinant. Welcome to Unacademy SN YouTube channel. This is K Umamaheswara Rao. Today we will be discussing problems on determinants. First problem. If det A is equal to 6 and if det A is equal to 6 and A is equal to ABC, PQR, XYZ. Then determinant value of 2A whole inverse is, then determinant value of 2A whole inverse is, now determinant value of 2A whole inverse is 1 by determinant value of 2A, 1 by 2 cube into det A, 1 by 2 cube into det A, one by 2 cube is nothing but 8, det A is 6. That's why 1 by 48 is the correct answer. 1 by 48 is the correct answer. Next column. Let AB n cross n matrix. N cross n matrix with entries 0 and 1, n greater than 1. If there is exactly one non-zero entry, in each row and each column of A, then the determinant value the determinant value of A must be, the determinant value of A must be. So here matrix is n cross n with each entry is either 0 or 1. If there is exactly one non-zero entry in each row and each column of A, then determinant value of A must be. Observe here. Suppose if you take determinant is 1 0 0 1, determinant value is 1. Suppose 0 1 1 0, determinant value is minus 1. So the value of determinant is either 1 or minus 1. In this problem, the value of determinant will be either 1 or minus 1. Next column, the number of terms in the expansion of determinant of order n is first option n square, second option n factorial, third option n, fourth option n plus 1 whole square. So the number of terms in the expansion of determinant of order n is, the number of terms in the expansion of determinant of order n is. Now suppose if you take determinant is 2 cross 2 a b c d, determinant value is given by ad minus bc, determinant value is given by ad minus bc. So 2 terms. Suppose determinant is abc xyz pqr, then determinant value is given by a of yr minus qz minus b of xr minus pz plus c of xq minus py. Here the number of terms are 6 terms. So the conclusion is, if the matrix is 2 cross 2, 2 terms. If the matrix is 3 cross 3, 6 terms. That means 3 factorial terms. If the matrix is 2 cross 2 factorial terms. If the matrix is of order n, then n factorial terms. So n factorial terms is the correct option. Next problem. Which one of the following is not equal to the determinant 1 1 1 xyz x square y square z square? Now first option is 1 1 1 x of x plus 1 y of y plus 1 z of z plus 1 x plus 1 y plus 1 z plus 1. Second option 1 1 1 x plus 1 y plus 1 z plus 1 x square plus 1 y square plus 1 z square plus 1. Third option 0 0 1 x minus y minus z z x square minus y square minus z square z square. Last option 2 2 1 x plus y plus z z x square plus y square plus z square z square. Now we have to find which of the following determinant is not equal to the given determinant. Now I am taking first option 1 1 1 x of x plus 1 means x square plus x, y square plus y, z square plus z, x plus 1, y plus 1, z plus 1. Now continuation. 1 1 1, x square y square z square, x square plus x, y square plus y, z square plus z, x y z plus 1 1 1 plus x, y square plus y, z square 1 1 1. Since two columns are identical, that's why the value of this determinant is 0. Now, this determinant can be written as sum of two determinants. 1 1 1, x square y square z square x y z plus 1 1 1, x square y square z square, here x y z observe here 1 1 1 1 1 1, x square y square z square x y z, x y z. Now because of these two columns are identical, this determinant value is 0, but here this can be written as 1 1 1 x square y square z square x y z. If you compare with original matrix, original determinant, observe this is the original determinant 1 1 1 x y z x square y square z square, but here we got the result 1 1 1 x square y square z square x y z. So two columns are interchanged from the original determinant, that's why minus 1 1 1 x y z x square y square z square. Now the given determinant is not equal to first option, so option A is the answer in this problem. Next problem. Let m power 4 is equal to I. M is not I, m square is not I, m cube is not I. Then for any natural number k, for any natural number k, m inverse is option A, m power 4k plus 1, m power 4k plus 2, m power 4k plus 3, m power 4k. Observe next problem, same problem. M power 4 is I. If m power 4 is I, we have to find out m inverse is m power 4k plus 1 or 4k plus 2 or 4k plus 3 or 4k plus 4k. Now, since m power 4 is I, now power k on both sides, m power 4 whole power k equal to I power k, m power 4k equal to I. M power 4k is I, m power 4 whole power k plus 1 is also I. M power 4k is I, m power 4 whole power k plus 1 is equal to I power k plus 1, that is also I. Continuation. M power 4k plus 4 equal to I. Now multiply with m inverse from left. 4k plus 4 minus 1 equal to I into m inverse. Now m power 4k plus 3 equal to m inverse. So the correct answer is m power 4k plus 3. Third option is correct. In this problem, third option. A, B, C, D are non-singular matrices such that A, B, C, D equal to I, then B inverse is A, B, C, D equal to I, then B inverse is. We have one trick to find out B inverse. Starting from B, follow counterclockwise order. C, D, A. That is the answer. Suppose you would like to find out C inverse. Follow from C, follow counterclockwise order. DAB. That is the answer. I am explaining how it is so. Now A, B, C, D equal to I. Now we have to find out B inverse. First, multiply this equation with A inverse from left. A inverse into A, B, C, D equal to A inverse into I. B, C, D equal to A inverse. Next, multiply this equation with D inverse. B, C, D inverse equal to A inverse D inverse. From this, we can write BC equal to A inverse D inverse. Next, multiply with C inverse on both sides. BC C inverse is A inverse D inverse C inverse. Now continuation. B is equal to A inverse D inverse C inverse. Now we have to find out B inverse. That's why take inverse on both sides. B inverse equal to A inverse D inverse C inverse whole inverse. This is nothing but C inverse whole inverse, D inverse whole inverse, A inverse whole inverse. C inverse whole inverse is C, D inverse whole inverse is D, A inverse whole inverse is A. Therefore, B inverse is CDA. The value of B inverse is CDA. Next problem. Different matrices that can be, the number of different matrices that can be with elements 0, 1, 2, 3, each matrix having 4 elements, each matrix having 4 elements is, first option 2 into 4 power 4, 3 into 4 power 4, 4 into 4 power 4, 3 into 2 power 4. So how many number of different matrices that can be formed with the elements 0, 1, 2, 3, each matrix having 4 elements. Now we have only 4 elements 0, 1, 2, 3. In this problem they have not specified the order of the matrix. That's why with 4 elements you can arrange either 1 cross 4 form or 4 cross 1 form or 2 cross 2 form. 1 cross 4 or 4 cross 1, 2 cross 2. So 3 different forms. In each form 3 different forms. In each form we have 4 blank places. Repetition is allowed because matrix. That's why in each place you can fill either with 0 or with 1 or with 2 or with 3, 4 ways. This blank you can fill 4 ways. This blank you can fill 4 ways. M1. Now matrix A, M cross N, matrix B, N cross P are multiplied. A11, A12, A1n, B11, B21, Bn1. Now, multiplying matrix AB, generally matrix multiplication is row of A multiplied with column of B. Now, if you multiply first row of A with first column of B, A11 multiplied with B11 plus A12 multiplied with B21 plus and so on. A1n multiplied with Bn1. Observe. That's why to create MP number of elements you have to multiply MP, you have to add MP n minus 1 times, you have to multiply MP n times. So MP n multiplications are required, MP n minus 1 additions are required. So MP n multiplications, MP into n minus 1 additions. So the total number of multiplicative operations are MPn and the total number of additive operations are MPn minus 1. Next problem. If A is equal to Aij M cross N is defined as Aij equal to I plus j for all ij, then the sum of all elements of A, then the sum of all elements of matrix A. Option A, Mn by 2 of M plus N plus 1, Mn by 2 of M plus N plus 2, M by 2 of n into n plus 1 by 2, n by 2 of m into m plus 1 by 2. Now, with the help of options, we can solve this problem very easily. Suppose if you would like to solve by conventional approach, you can solve like this. A is equal to m cross n. M cross n. M rows, n columns. A11, A12, A1n. A21, A22, A2n. AM1, AM2, AMN. A11, 1 plus 1. Because AI is A equal to I plus J. So A12 is 1 plus 2. A1n is 1 plus n. A21 is 2 plus 1. A22 is 2 plus 2. A2n is 2 plus n. AM1, m plus 1. AM2, m plus 2. AMN, m plus n. Now, observe. If you add all first entries like this, 1, 1, 1, how many times? 1, 1, 1, n times. So, n number of ones. Plus 1 plus 2 plus 3 plus n. N into n plus 1 by 2. That is first row. What about second row? 2, 2, 2. How many times? N times. So, n into 2 plus 1, 2, n. 1 plus 2 plus and so on n. N into n plus 1 by 2. Called it equation 2. Next, last row. M, M, M. How many times? N times. N number of m's plus 1 plus 2 plus and so on n. How many times? 1 plus 2 plus and so on n into n plus 1 by 2 sigma n. Called it m. Mth equation. Because mth row is last row. So here you have m number of n into n plus 1 by 2. Therefore, you can write m number of n into n plus 1 by 2. Next, n, n, n. If you take n common, you will get n of 1 plus 2 plus and so on m. So, n number of sigma m. Sigma m means m into m plus 1 by 2. So here m of n into n plus 1 by 2. If you take mn by 2 common, m plus 1 plus n plus 1. That is mn by 2 of m plus n plus 2. Final answer is mn by 2 of m plus n plus 2. This is the approach if you would like to solve directly. Suppose if you use the options, you will get the answer very easily. Next problem. Let matrix A 1 by 9 minus 4 by 9 8 by 9 8 by 9 4 by 9 1 by 9 alpha by 9 minus 7 by 9 beta by 9 for some alpha comma beta belongs to R if A is orthogonal matrix, then alpha equal to beta equal to. So we have to find alpha beta values if the matrix is orthogonal matrix. If the matrix is orthogonal matrix, then what are the values of alpha and beta? Now, the matrix is orthogonal matrix. Matrix is orthogonal matrix means A into A transpose equal to I. A into A transpose equal to I, then the matrix is known as orthogonal matrix. Otherwise, you can use another logic. Orthogonal matrix is always combination of collection of orthonormal vectors. Each row vector and each column vector in this matrix are orthonormal vectors. That's why they are the collection